In our first section, 6A, we were talking about qualitative descriptions, like how the data looks. But in 6B, we're going to be talking more about the numerical side of it. So we would say that 6B is looking at our data in a quantitative manner when we look at these measures of variation. Okay? All right. So let's start off with why variation matters. Okay, and in our last section we talked a little bit how that there can be a lot of variation or a small amount of variation. In fact, the last thing that you did in section 5A was about low variation or high variation or no variation. And so now we're going to talk about why it matters. So first off, let's consider the following wait times for 11 customers at 2 banks. At Big Bank there are 3 lines. And at Best Bank, there's 1 line. So at Big Bank, you can basically pick any of 3 lines and go to 3 different tellers. At Best Bank, there's 1 line, and you wait your turn, and when a teller's ready, one of those tellers will call you to come to them. So what is happening here is you can see that at the Big Bank, it kind of varies a lot as to what your wait time will be. Some people have here at 4 minutes of wait time, where some of them are up here at 11. At the Best Bank, you can see that everyone has 7 to 8 minutes of wait time. In fact, if you actually do the division and you add these up and find the average, if you add these up, you get 79.2 minutes, and you divide that by 11, and the average wait time at Big Bank is 7.2 seconds. The average wait time at the Best Bank, if you do the division, is also 7.2 seconds. So their average wait time is actually the same. But which bank do you think is more likely to have unhappy customers? And then because of the fact that there's a lot of variation in the Big Bank, we would say that generally they would have more unhappy customers because it's more unpredictable. It's less likely for them to know how long their wait will be. And so if they have these surprise wait times, they might be more frustrated because they see that maybe the person that went before them in a different line is moving more quickly. And so maybe they feel like they're treated unfairly. So if it feels more fair to them and everyone has approximately the same wait time, then these customers will actually probably be more satisfied. And all in all, it averages out to the same wait time either way. Okay, so we can see now why variation may actually matter here. Okay, the next thing we're going to talk about is range. And the range of a data set is the difference between the highest and the lowest value. So you're actually just going to subtract your highest value, which we also call the maximum. You're going to subtract your highest and your lowest values from each other. Okay, so we're going to do a little practice with that. So let's consider the following 2 sets of scores for 9 students. Which one has a greater range? And would you also say that the scores in the set are more varied if it has a greater range? So let's see. So if we take the range of the first quiz, and again from the previous slide, our range is actually the difference in the highest and lowest. So our highest value is a 10, our lowest is a 1, 10 minus 1 is 9, so our range is 9. And then for quiz 2, our lowest and highest are, the highest is 10, the lowest is 2, so 10 minus 2 is 8. So actually we can see here that quiz 1 has a higher range, but if you actually look at the values, you notice that quiz 2 has more variation. Quiz 1, you can see that all but 1 scored 10, and then on quiz 2 you can see that they're all varied here. So we'd actually have 2 comments we can make, and over here on slide 2, about the misleading range, you could say that quiz 1 has a greater range, but quiz 2 actually has more variation. So don't assume that just because it has a larger range that it varies more. So you actually have to look at the data and look at the actual points in your data. Okay, so now we're going to talk a little bit about how we take our data and we divide it and we do other things with it as well. Okay, so we're going to be talking about quartiles, and this is where we're going to take our data and our set of numbers and we're going to divide them into parts. Okay, we're going to be dividing our data into 4 equal parts, and we're going to do that by finding what we call the lower, middle, and upper quartiles. Okay, the lower quartile sometimes is called the first quartile or sometimes Q1. It divides the lowest fourth of the data set from the upper 3/4. Okay, now the word quartile, that insinuates that you realize there are 4 parts. And so the lower quartile is like the cutoff mark for the first fourth of the data. So like you can see down here in this picture, that the lower quartile is this mark right here that separates the first 25% from the other 75%, or the first 1/4 of the data from the other 3/4 of the data that you can see here. Okay, it is the median of the data values in the lower half of the data. So what it's also showing you here is that if you were to take the lower half of the data, which would be from here on down, if you were to take just this lower half, the lower quartile falls right in the middle of the lower half of all the data. So the lower 50%, the quartile 1, or the first quartile, lower quartile, however you're naming that, will be marking the halfway mark of the lower half of all of the data. Okay, then we have what's called the middle quartile. The middle quartile is actually the median of the entire data set. So that's what we have here. It's the median of the entire set of data, and it's marked here in the picture that it is right in the middle at the 50% mark, or the halfway mark of the data. Then we have what's called an upper quartile. The upper quartile is also called the third quartile, or Q3, and it takes the top 50% of the data, and it is the middle of that top 50%, and it also divides the top quarter from the lower 3/4. So you can see that this 25% up here is 1/4, where there's 3/4 below it. Okay, so we have three values that we're concerned with right now. We have the lower, middle, and upper quartile. The lower quartile is right here, the upper quartile right here, the middle quartile right there. And so basically what this has done is it divides your data into 4 parts, where there should be 25% represented in each of those 4 pieces, so that it totals to 100%. Okay, so we're going to move on, and we're actually going to use this information. We're going to take these numbers we just talked about, and we're going to do what's called a 5-number summary. A 5-number summary for a data set consists of the following 5 numbers. It will have the numbers we just talked about, the lower, middle, and upper quartiles, and we did mention that the middle quartile is also the middle of all the data, which we also call the median. Okay, so quartile 1, quartile 2, quartile 3, or we can call this lower, middle, and upper quartile. Those are 3 of these numbers. Then we also want to pay close attention to what our low value is and what our high value is. Okay, and what we're going to do is this 5-number summary, we're going to take it and we're going to draw what's called a box plot. A box plot shows the 5-number summary visually with a rectangular box that encloses the lower and upper quartiles. So you can see that right here. This box in the middle is going to have the lower quartile on one side, the upper on the other, and it's going to enclose those together. And there's going to be a line that marks the median, which we also call quartile 2. And then there's going to be whiskers, okay, that come out here to the edges to show the low and high values. In fact, sometimes this box plot has also been called a box and whisker plot because it looks like it's a box with whiskers coming off either side. Now we're going to take our box plot steps, and we're going to go through these, and we're going to create our own box plot for a set of data. Now I do want you to note that this excludes any outliers that there might be in a set of data. The way that we're doing this, there is a second way to do this with outliers, but what we're talking about right now is just excluding any outliers, so anything that's just way too high or way too low that just totally doesn't make sense within our set of data that we know is going to be skewing our data. So that would be, we just consider that we don't have any of those right now. So in our data, we don't worry about outliers at this point. Okay, these are the steps to making a box plot. First, you're going to order your data from least to greatest. Then you're going to find each of the 5 numbers in the 5-number summary. You're going to draw a number line that will contain all the values of the 5-number summary, so we have to make sure our line will be able to contain that. And then we're going to draw a line for the median, lower, and upper quartiles to divide them. We're going to make a box that connects the lower and upper, and then draw a dot or a line out to the minimum and the maximum to make those whiskers that we were talking about. We're going to connect those dots to the center left and right of the box plot. Okay, so let's take our set of data. For our big bank and our best bank, we're going to make a 5-number summary for each one of those because we're actually going to have 2 box plots that we're going to draw here, and just kind of helps us have a little better visual representation. So if you look at big bank, our big bank has these values right here. Now notice that they are already in order from least to greatest, so that's the first step. And then we're going to have to identify our lower, middle, and upper quartiles, and then our low and our high values. Okay, so if we take a look at this first set for big bank, we can see that the middle of all of the data, and in fact that's usually where we start, is actually the median of all of the data, because the lower quartile is going to divide the bottom half, the upper is going to divide the upper half. So let's find the middle of all the data. Well, there are 11 numbers in this data set, so there's going to be one in the very middle. All right, so that's going to make 5 come before it and 5 come after it. 7.2 would be our Q2 right here. This is our quartile 2, also called the middle quartile, or it's actually the median of the entire set of data. Okay, now once once you have quartile 2, you can take and look at the bottom half of your data from here down, and you're going to take these 5 numbers and you're going to find the middle of those to get what's called your lower quartile. So there are 5 values right here, so that means the third one's going to be in the middle, or you can do like we've done before and cross end, front, and end in front, and you'll see that 5.6 is in the middle. This is going to be our Q1. So there you go, we have our lower quartile. And then we're going to come up here and we're going to do the same thing. We're going to take this top half of the data and find the middle of these 5 numbers. One from the in front, you work your way up, and you see that we have 8.5 right in the middle. Okay, so that's our upper quartile. And then we're going to list our low value, which is 4.1. and our high value, which is 11.0. So we have our 5 numbers in our 5-number summary for the big bank. And then we're going to do the same thing for the best bank. If you'd like to pause and try that on your own, go ahead, and then you can unpause and you can check. So the middle of our numbers here is going to be 7.2, so that's going to be our median. So we're going to start there. And then we're going to take the lower half, find the middle of the lower half, which is the 6.7, and then the middle of the upper half, which is the 7.7, to get our Q1 and our Q3. So there's our 6.7 for our lower quartile and our 7.7 for our upper quartile. And then we're going to take our low value and our high value. And we have those 5 listed here. So now we have a 5-number summary for each of the banks. Okay, now you should have some space on your next slide for you to go ahead and draw basically like a graph that you can plot these on. Okay, so you can just take a simple straight edge of some sort, protractor or edge of your paper, and just draw yourself a horizontal and vertical axis. This is your vertical axis. Down here's your horizontal axis. I can see that my values here are ranging from about 4, I believe is the lowest one, 4.1, and it goes up to 11.0. So I'm just making sure that my numbers are ranging from 0 up to 12 down here. So basically I just divided this into 4 equal parts across the bottom, approximately 4 equal parts, so that I could get 0, 3, 6, 9, and then you can just break that apart a little bit more. Just kind of visualize it. It doesn't have to be perfect. Okay. So we have our 1, 2, put our 4, 5 in here. Okay, so now I have my waiting time across the bottom from 0 to 12 minutes, and then I have my 2 banks because I'm going to have one plot here and then another one above it for each of those banks.